So this is the last unit of the entire first semester, right? We're going to use proofs using coordinate geometry. Remember, coordinate geometry involves the distance formula, the midpoint formula, and the slope formula. So let's see if we can prove that the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. We know equidistance means that it has the same distance. So what I want to do is first find point M, the midpoint of the hypotenuse. And then I want to compare the distances using my distance formula of EM, OM, and FM. All right, so step one. Find the midpoint of M using the midpoint formula. Remember, I'm going to add my x's together, divide by 2. Add my y's together and divide by 2. So let's see. Actually, this should be the midpoint of EF, use midpoint formula, and that is point M that I'm looking for. All right, so add our x's together, 0 plus 2a. So I'm adding 0 plus 2a. And then 2b plus 0 divided by 2. So the midpoint is 2a divided by 2 is just a. And then 2b divided by 2 is b. So point M has the coordinates a, comma, and we know the coordinates of the origin are also 0, 0. So what I'm going to do next is to use the distance formula to find EM, FM, and OM. Remember how I set those up? Same thing we were doing before. Let's set each of those up, and then I'm just going to plug in the points. I'll pause there because you caught up. So now I'm going to plug in the points. So point E, plug in my 0 there. Let me choose a different color for that. So point E, 0 and 2B, I'm going to drop there and there. And then M, I'm going to put A and B there. And now I can simplify. Negative a squared. Okay, so an a times negative a times a negative a, just a squared. And then 2b minus b is, I'm just going to leave it just like that. Remember, I'm just comparing the distance. I want to see if they're the same distance. I want to see if it's the same distance. So Fm, we put 2a and 0. and M is A and B. So now what I get, 2A minus A is A squared. And then negative B times negative B is B squared. All right, so EM and FM are congruent. Now let's check out OM. So OM, I'll put my O there, 0, 0, and then A and B there. So now I have negative A squared, which is just A squared, and negative B squared, which is just B squared. So notice they all have the same lengths. So we can conclude that EM equals FM equals OM because they all equal the square root of A squared plus B squared. Therefore, the midpoint of the hypotenuse of a right triangle is equidistant from the vertices. All right, you might want to write a little bit small for this one. We're going to prove that trapezoid mid-segment theorem. That if we have a mid-segment that connects the midpoints of our legs of our trapezoid, it's parallel to the top and bottom, and it's half as long as the sum of the top and bottom. All right, so the very first thing we need to do is find points M and N using our midpoint formula. All right. So that would be the midpoint of our O. We're going to write that coordinates for O right there. That's 0, 0. Remember, we're going to add our x's together, divide by 2. Add our y's together, divide by 2. And then I also want to find the midpoint of AP. So I'm going to, again, add my x's together, divide by 2. Add my y's together, divide by 2. All right, so let's start with our O. So I have 2b plus 0 divided by 2, and then 2c plus 0 divided by 2. Point M is going to be the point B comma C. 2b plus 0 is 2b. 2b divided by 2 is 3. And then the midpoint of AP, we're going to have 2a plus 2d divided by 2, and then 2c plus 0 divided by 2. So point N is going to be point A plus D, comma C. I'm going to write those in here just for ease of use. BC. And this is A plus B, comma C. Questions on that part? We can find the midpoint. Step 2. Use slope formula to determine MN is parallel to OP, and that's parallel RA. What I'm looking for is that they all have the same slope. I can verify that they're parallel. Alright. Let's set up our slope formulas. So we have our, let's see, OP, MN, and RA. So our slope of MN, Y's on top of their own X's. And then our slope of, actually that's the first one I'm going to do OP. Let's do OP then MN. Let's work our way up. And my slope of MN. And then my slope of RA. I'm going to find all three of these slopes. See if they're the same. So for each of those coordinates, I want to put y's on top of their own x's. So for OP, I'm going to put y on top of its own x, 0 over 2a, and y on top of its own x, 0 over 0. And then mn, that next one up there, I have c over b. And then I have c over a plus b. And then the top one, RA, I have 2c over 2b. And I have 2c over 2d. So I put my y's on top of each of the x's, and then I just need to simplify to find these slopes. So 0 minus 0, I end up with 0 over 2a. 0 divided by anything is 0, so the slope of OP is 0. C minus C is 0. And I have B minus A minus D on the bottom, but 0 divided by anything is 0. So the slope of MN equals 0. 2C minus 2C on the top there is 0. So I have 0 over 2B minus 2D. So I have a slope of RA equals 0. Therefore, that first one is done. MN is parallel to OP, parallel to RA, because they all have the same slope. The last part of the trapezoid midsegment theorem I want to prove is that the midsegment is half the length of the sum of the two bases. So we want to use the distance formula to compare MN, OP, and RA. So I want to do the distance formula a couple of times. And then RA down here. All right. I'll wait for you to get those shells filled out, and then we'll start plugging in our x's together and our y's go together. Remember, distance formula is easy. Put the x's together in one parentheses, y's together in the other. So, OP, let's put our x's together and our y's together. So I'm going to plug these in with blue. We have 0 and 0, and then 2a and 0. So I end up with the square root of negative 2a squared, which equals the square root of 4a squared. So OP simply equals 2a. Square root of 4 is 2. Square root of a squared is simply a. Mn, put our x's together. A plus d. C goes over there, and then B here, and C there. So what I end up with here is square root of A plus D minus B squared, which means Mn equals A plus D minus. So C minus C is 0, so that just goes away. And then, all right, let's put our x's together. 2D and 2C, 2B and 2C. So we have 0 over here again. So RA equals the square root of 2D minus 2B squared. So RA simply equals 2D minus 2B. All right. Lastly, let's compare using the mid segment here. So I want to know that whether or not Mn equals OP plus RA divided by 2. All right, so let's plug these in. So I have Mn, A plus D minus B. Does that equal OP here? 2A plus RA, 2D minus 2B, all divided by. So on the top here, what can I factor out of each of those? Take out a 2. And then I can cancel through multiplication. And I get A plus D minus B equals A plus D minus B. Is that a true statement? Yes, that is an identity, a true statement. So the mid segment of a trapezoid is half the sum of the bases.